I hope that y'all are ready to use a pH meter. Here is a video guide from our lab of acids and bases to help. First, this group member is going to take the cap off safely from the pH probe in order to not mess up the glass probe in the front of it or the bottom of it, and use the pH meter to calibrate using a 2-point calibration as seen in the video. He is going to first put in the pH that he is measuring first and is going to wait for the voltage, which shown is around 5,000, to level out, and then is going to clean off his pH probe and test with a different pH, now either 4 or 7, and remeasure that. After the pH probe and pH meter have been calibrated, this group member is going to clean off his pH meter and then measure one of the pHs of the solutions that we are given. Once the student and group member has measured out via the pH probe, he is going to safely store the pH meter, making sure to not again mess up the glass pH probe, and then record the following results of pH in a well-labeled table in his lab notebook. The difference in dissociation behavior with protons and strong acids and weak acids is that strong acids in general will dissociate completely because they have very weak conjugate bases, which means that they readily want to give up a proton to water. Weak acids, on the other hand, only partially dissociate because a weak acid has a stronger conjugate base, which means that it will easily accept protons for water and not give those protons away. And this helps to lead and establish an equilibrium between an undissociated acid and its conjugate base. You can see here that a lab member is testing the pH with a pH meter of apple juice, and once it is found, goes into a lab notebook and writes down the pH value next to the apple juice note. Here are some steps that we can take to help minimize this effect of equilibrium. We can increase the concentration of the acid, which helps to increase the rate of the protons donating and helps to shift the equilibrium towards a dissociated state. We can decrease the concentration of the conjugate base, which helps to decrease the rate of proton acceptance and shifts the equilibrium towards an undissociated state. We can also increase the temperature, which helps to increase the rate of the protons giving away and shifts the equilibrium back towards a dissociated state, since the dissociation of weak acids is usually endothermic. As seen in these videos, all of the pH meter calibration is done by using 2 buffer solutions, one of pH 4 and one of pH 7. These buffers are solutions that can resist pH change upon the addition of acidic or basic solutions. This is because these buffers are able to neutralize small amounts of acids or bases that are added and helps to maintain the pH of the solution relatively stable compared to other solutions that are being tested with. These buffers are also made by mixing a large volume of weak acids or weak bases together with its conjugate. We hope that this video has helped with the acids and bases lab and with a pH meter. Good luck!